and I work as an associate software engineer in platform squad of XenonStack. So I'm here today to talk about blockchain. Blockchain is not a relatively new technology. However, it has made quite a buzz in the recent few years. So what is blockchain? Blockchain is a distributed database management system which is highly secure, immutable, and transparent. It is maintained using a set of computers called nodes, which could be at different physical locations, and it is secured by cryptography while being constantly updated by its consensus protocols. So that is blockchain in a nutshell. We'll dive deeper into how its architecture works and what problem statements could be solved with it, and how is it better than a traditional database. So let's talk about a few problems where traditional databases are currently being used, but those services could be highly improved by the use of blockchain. Suppose we have a situation where multiple rivaling companies are working together on a project. They have to share a common database. Now, each of these rivaling companies cannot trust the other that they will not modify the database if they have the access and not leave a trace in about it. So, how blockchain could be implemented here is, as we know, blockchain is highly transparent. So everyone can see what is made, what kind of changes are made to it, when the changes are made, and by whom the changes are made. So this provides a level of trust which normal databases cannot provide. Another example would be online voting systems. So till date, voting and elections have only been done in the physical way, like going to the booth and putting in our votes. And this is because we cannot trust with votes being stored in a database and that database to be managed by a single entity. So how blockchain will help us here is that it will create a very transparent database where every transaction will be recorded and be visible to everyone who is making changes, and when or how the changes are made. Everything will be visible in a blockchain. This is a high-level overview of how blockchain can be used in two of the most important use cases of blockchain. These use cases are not the solutions for these use cases are provided by traditional databases, but are not that trustable. So we implement blockchain in these scenarios. So let's now talk about the working principles of blockchain. What are the fundamental principles that make blockchain what it is? So the first one is decentralized. Being decentralized is a big part of blockchain. There is no single authority or some entity that controls the database of blockchain. Second is immutability and retraceability. Blockchain is a ledger first and a database second. What that means is that whatever is stored or whatever transaction is made in blockchain, it is recorded permanently and it cannot be erased. And the same way goes for retraceability of blockchain. Since it is a ledger, we can trace back whatever transactions have happened. And the third is trustless agreements. Trustless agreements mean, let's understand this with an example. Suppose we buy an insurance from an insurance company. We pay it every month. In the event that we meet with an accident or some misfortune happens with us. Now we have paid the insurance company some money every month so that it will bail us out when we are in trouble. But the trouble is that insurance companies are not in the business of giving out money. They are in the business of making money. So they will try to find out any loophole in the contract that we have signed with them so that they can pay as less money as possible. However, with blockchains, we do not need to trust any contract or any agreement. It is all written in code. Therefore, whatever we lay out the conditions, those will be executed automatically when the conditions are met. Trust on brand value. Suppose we continue our first example. If we are met with an accident and we did not get our claim settlement from our insurance company, what we can do? What we can do now is we can go to another insurance company, and we have to trust over their brand value. We have to trust that they will follow what they have written down in their agreement. But this is not very feasible. In case of blockchain, there is no such issue of trusting. Everything is written down on smart contracts, and these smart contracts execute themselves automatically. So there is no need of trusting on any brand. This is how blockchain works. So let's now actually understand how a blockchain works. Before that, let's understand what are the kinds of blockchain. There are basically two different kinds of blockchain: public blockchain and private blockchain. Public blockchains are used for applications like cryptocurrency and other decentralized apps. And private networks are used where private companies or a group of companies work together on a same database. So this is the working of a private blockchain like Hyperledger Fabric. So let's first understand what are the components in this Hyperledger Fabric blockchain. So let's look at our first component. This is the peer or a set of peers. Every blockchain network has a set of nodes. In Hyperledger Fabric, these are called peers. Peers are of two kinds: endorsers and committers. How do these work we'll understand later on, but for now we'll understand that peers contain the ledger, that is the record of all the transactions in the blockchain network, and the chain code. Chain code are the set of rules that are defined in the smart contract. And second is the client application, which are made using software development kits provided by Hyperledger Fabric itself. And these SDKs are provided in many different languages like Go, JavaScript, Java. And the third major component of Hyperledger Fabric are the ordering service. So what are ordering services? Ordering services are basically peers that order the transactions into a block and then send it to peers to put it in the blockchain network. And above here we can see the membership services. Now membership services provide us an important aspect of blockchain, Hyperledger Fabric blockchain. In Hyperledger Fabric is a permission blockchain, which means that everyone who accesses it, their identity is known and verified. This verification is done on the basis of certificates. Certificates are provided by certification authorities. Now, these membership services provide the certificates either from an external certificate authority or from the Fabric certificate authority. So, now that we have understood the components, let's begin understanding the flow of a transaction in Hyperledger Fabric. It begins with the client making a proposal for a transaction to be added on the blockchain. This proposal is sent to an endorser peer. Endorser peer will check according to the chain code written on it that is the proposal valid and can we add it to the ledger. It also checks if the certificates that are provided by the client are valid. After verifying the validity of both the things, it sends back the transaction to the client. And then the client sends it to the ordering service. The ordering service, after receiving the transaction proposal, it just does ordering of the transaction. That is the order in which the transactions are made, and puts it in the block to be added in the blockchain. It sends the block to the committer. These committers will actually put the blocks into the blockchain. After this, the response is sent back to the client, informing them that their transaction has been recorded and added to the ledger. Now this transaction, once added in the ledger, it is immutable. Nothing could change it. Not even endorser peers or the ordering service or the committers. So these are immutable. This allows for a very specific functionality of Hyperledger Fabric, which is retraceability. Now, we'll understand this by solving the problem statements that we talked about in the beginning. Suppose we have a voting system. Voting system requires true transparency to see who has voted. So the problem statements we talked about in the beginning were electronic voting system. In electronic voting system, there is a problem of database management. How? The database management is done by backend developers or database administrators. They can completely change or modify the database without even leaving a trace. This is a major concern as any kind of traditional database is maintained by database administrators. So what blockchain does is blockchain is a ledger. Every transaction that has been made into it is recorded. So no unnoticed transactions go inside. And another use case for this would be trading consortiums. Trading consortiums can use this to enhance their functionality. Many trading operations take several days to get verified by a single entity due to the sheer volume of the transactions. But due to blockchain, this problem is solved because these transactions and their validity are done automatically based on the smart contracts by the sheer volume of data. Blockchain allows everyone to transact openly and manage their paperwork electronically. Blockchain also benefits supply chain networks. In some vast supply chain networks, every transaction recorded on blockchain will be open and visible to everyone, hence reducing the risk of counterfeit. These are the various use cases of blockchain. Risk of counterfeit. So these are the various use cases where blockchain distributed architecture helps in bringing about transparency to the transactions and enables more security in the database. Blockchain's aim is to bring transparency to end consumers so that they can see what is happening with their valuable data. This also helps clients to gain trust from their customers by keeping their choices and preferences safe and immutable. So this is how experimental Saturdays at XenonStack have helped me to learn about a completely new technology like blockchain and its application. I am sure that this will help me in many ways. Thank you everyone for watching the video and hope you have learned a bit about blockchain.